Hi, welcome to a brief explanation of arsenic, its effects on us and the environment, and how we can remove it from our water. This won't be an incredibly in-depth video, but I've linked an article in the description that explains everything with the proper scientific terminology. You may need to use a school email to see this article, but if you're interested, it's very helpful. Without further ado, let's start. We'll start with a quick overview on arsenic itself. Arsenic, or AS as it's most commonly abbreviated, is a heavy metal that has been recently contaminating a lot of waters, especially in Southeast Asia. It comes from a few sources. Volcanoes and minerals contain arsenic in trace amounts, so when eruption or erosion occurs, small amounts are going to be deposited into our waters. But it's not a lot, and humans can usually resist whatever amounts they may find. What has pushed us over the limit has been industry and agriculture. Obviously, we've been doing a lot more industry and agriculture within the past 150 years, so the small amounts of arsenic that are exuded by these processes have been magnified, and it's gotten to the point where it's outpaced the natural processes that take out arsenic, and we have seen increases in concentration around the world. You may be wondering, though, why do we care if there's more arsenic in our waters? And that's because arsenic is generally harmful for people. It's considered a carcinogen, which means that it causes cancer, or at least increases the chance of getting cancer. It can cause skin issues such as hyperpigmentation, it can cause respiratory issues such as asthma, and it harms plants by limiting their growth, limiting their reproduction, and if there's too much arsenic, plants will just die. So generally, yeah, it's pretty bad, which is why we want to get rid of it. That does bring us to the question, though, how do we get rid of it? And scientists have already figured out a way. It's called adsorption. Essentially, it works by putting a removal agent into the water and arsenic sticking to it like tape. It'll just get stuck to the surface. As you can see, you put it in, they just clumps onto it, and then you take it out, and there's less arsenic in the water. The actual mechanisms of adsorption are pretty complicated, but that's not really important for this lesson. So we're just going to move on to the different types of removal agents that we have. Now, there are a lot of different removal agents just based off of chemical structure, but they can mainly be classified into three main types: single-walled, multi-walled, and graphene sheets. All three of these share the same kind of hex grid pattern chemically, so you're going to see this for all of them. It's just how they're formed. So obviously, single-walled carbon nanotubes are just one single layer of this hex grid looped into one roll. Generally, they're the quickest acting, but they don't really absorb too much. While multi-walls, compared to single walls, have a larger absorption capability, but they're slower acting. So it's kind of just a situation of which one do you want? Do you want quicker but less, or more but slower? But these carbon nanotubes have an issue that I haven't explained yet. So there's two types of arsenic, arsenic 5 and arsenic 3. Arsenic 3 is actually way more toxic to humans than arsenic 5. So, and unfortunately, carbon nanotubes don't do a great job at containing arsenic 3. They don't capture them, they mainly grab arsenic 5. Graphene sheets, on the other hand, they're stacked like this, and they do a great job at capturing arsenic 3. So, like I said, there's multitudes of different carbon nanotubes and graphene sheets that each have their own little quirks. Some single walls will be better than other single walls at certain things. Some multi walls will be better at other multi walls, but generally those are the only broad differences between the different types. So lastly, I want to talk about the future of research and the issues that we currently have with it. So right now, carbon nanotubes and graphene are expensive. They're really costly, and they're just not really worth it. And that's because the materials that we use to make them out of are costly, and they're not reusable. So we use them once, and we have to throw them out. Now, people have tried already to use less costly materials for carbon nanotubes or graphene sheets, and it's just not worked. So we need to focus on fixing the not reusable part. If we're able to reuse it once, twice, maybe even 3 times, it'll increase the cost effectiveness like tenfold. So that's probably where most of the research is going to go in the future. Outside of cost, basically it's just going to be we want these carbon nanotubes to absorb more, and we just want them to act faster. Outside of that, there's not really much else that has much promise in future research. And yeah, thank you for listening.